All right, today we're going to take a look at our last day of solving trig equations. But before we do that, we're going to take a look at solving for y in these just algebraic problems. All right, so here it is absolutely possible to divide both sides by x, provided that we know that x is not 0. So here I can get y equals 1 over x, and we're good to go. So the next one, we cannot divide both sides by x, because if we were to divide by x, those x's would be gone. So the x completely disappears from the equation. So what we want to do instead when we have an x on both sides is we want to get everything on one side. So I get xy minus x equals 0, and I want to factor out that x. So I get y minus 1 equals 0. And then we can solve for y there. We can set both of them equal to 0 and go from there. All right, same idea applies to our trig functions. It is absolutely possible to divide both sides by cosine here. I would get 2 is equal to tangent of theta, and then I could go on and solve using my calculator from there. Okay, but in this next one, we absolutely cannot divide both sides by cosine because it would eliminate that cosine completely. And the one thing we have to be careful with in that first problem is that cosine can't be 0 in order for us to divide, because you can't divide by 0. But in the second example, we've got to move that cosine over just like we did before. So it'd be 2 cosine sine theta minus cosine theta equals 0. And then notice you have a cosine in both, so we could solve this by factoring. We could pull out a cosine theta. We get 2 sine theta minus 1 equals 0. And then we can continue and solve from there. Okay, so you can divide both sides by cosine if that cosine does not get eliminated. All right, when do we use substitution and when do we find all of the solutions using k? So obviously if it says solve for all solutions, then we know that our answer is going to be something like, x equals pi over 2 plus 2 pi times k, where k is an integer. Okay, also if we have those unique angles, those 4 thetas or those 3 theta minus pi over 2, and identity doesn't help us there, that's when we're going to do substitution, and that's when we're going to find the all solutions. So remember, we took this out, we substituted, and we said tangent of x equals, 1 or whatever it's equal to. We solve for 1, the all solutions equation, and then we have to plug that 4 theta back in. Okay, a couple other things that we can do to solve. One of those steps is to factor, which we did over the last couple days. Substitute in some identities, right? Get rid of that sine squared, plug in a 1 minus cosine squared if everything else is in cosines. We can multiply or divide both sides by sine or cosine, etc. And then the fourth thing we can do is we can square both sides. The one thing we have to remember when we square both sides is that you have to check your solutions. So you got to plug your answers back into the equation to make sure that they check. All right, so let's take a look at some examples. So this first one, I've got sine of 2 theta equals cosine theta, and we're solving this one from 0 to 2 pi. So looking at our identities or looking at our angles, I've got a 2 theta and a theta. So the first thing we've got to do is we've got to fix those. We've got to turn them all into thetas. So I know that sine of 2 theta is 2 sine cosine, and that's from our identity sheet. Okay, and that actually looks like the problem that we just did on that first page. I cannot divide both sides by cosine because it would make my cosines become eliminated. So I want to move that cosine over. So it's 2 sine cosine theta minus a cosine theta equals 0. Now, since I have a cosine in both, I can factor out a cosine theta. And that gives me a 2 sine minus 1 in the parentheses. And now that it's factored, we can take both of those and set it equal to 0. So we've got cosine theta equals 0. And then 2 sine theta minus 1 equals 0. So that gives me sine theta equals a half. So again, we're in radians. So where is cosine 0? Theta is cosine 0 at pi over 2 and at 3 pi over 2. So there's my solutions from the first one. And then look around your unit circle. We know sine's positive in quadrants 1 and 2, and that happens to be a half at pi over 6. As well as 5 pi over 6. All right, our next example, tangent squared equals 3 halves secant theta, and we're going to do that again in radians. Okay, so I know that tangent squared is sine squared over cosine squared. Okay, and I know that this is 3/2, and secant puts a cosine down on the bottom. Okay, so one of the things that we can do is we can multiply or divide both sides by the same thing. So our common denominator here would be a 2 and a cosine squared. So I want to multiply both sides of this equation by 2 cosine squared. So again, we can multiply both sides by the same number, and a 2 and a cosine squared will get rid of our denominators. So here the cosine squareds are gone, so I'm left with 2 sine theta. And on the other side, both the 2's go as well as one of the cosines. So I'm left with a 3, oh, that was a sine squared on the left side, and a 3 cosine theta. All right, so I have a sine squared and I have a cosine, so we know that we need to get rid of that sine squared, so we can do that substitution of 2 minus cosine squared equals 3 cosine. If we go ahead and distribute here, I can get a 2 minus 2 cosine squared equals 3 cosine theta. I never want my squared term to be negative, so we're going to go ahead and move everything to the right side. So that gives me 0. If I'm going to add 2 cosine squared to the other side, that gives me a 2 cosine squared plus a 3 cosine theta. And if I move this 2 over to the other side, it becomes a minus 2. All right, so here we can go ahead and we can factor and we can solve just like we did some of the other days. So the main idea is to get that tangent to be a fraction and the secant to be a fraction, and then multiply both sides by the same, in this case, the 2 cosine squared. We've got to multiply both sides by the same trig function. All right, so next one, I've got sine equals cosine plus root 2. Okay, so that root 2 isn't nice. So what we want to do is we're going to have to square both sides here, right? We want to get rid of that root 2. So let's move that sine over to the other, or that cosine to the other side. So I've got sine minus cosine theta equals root 2. And again, when we have sines and cosines, we really can't deal with those until they're sine squareds. Okay, so the easiest thing to do here to solve is to square both sides. Okay, so remember, when we square both sides, that means we've got to multiply sine minus cosine times sine minus cosine. So we're going to have to distribute that out. So that gives me a sine squared theta. On the outside, I get a negative sine cosine. On the inside, I get a negative sine cosine. So that really gives me negative 2 sine theta cosine theta. And at the end, I get a positive cosine squared. And then if I square root 2, that just gives me 2. So one of the things, hopefully, that you're getting better at seeing is our identities. I've got a sine squared and a plus cosine squared. We know that that's 1. So now I've got 1 minus 2 sine theta cosine theta equals 2. I can move that 1 over, so I get negative 2 sine theta cosine theta equals 1. Okay, now I don't want to divide by negative 2. Because hopefully, again, you see that identity, that 2 sine cosine is on our identity sheet. That's sine of 2 theta. So all we really need to do is to get rid of that negative sign, so multiply or divide both sides by negative 1. So now that's sine theta, or sine of 2 theta equals negative 1. Okay, and here we can continue and we could do the substitution. And it's the double angle, so that's where we're going to plug in x. We're going to solve the all solutions and then plug that 2 theta back in like we did on day 2. Okay, so again, what we're focusing on today is how do I get to a point like this part right here where I know how to solve. Okay, and we've already spent time solving those, so I'm going to spare you a little bit of time and not continue to solve those. But we've got to do that substitution and go from there. All right, so let's take a look at the next one. So the next one is cosine equals secant. Okay, so again, I know that I've got a cosine theta here, and this is 1 over cosine. Okay, so this is where we want to multiply both sides, right? Our denominator is cosine, so I want to multiply both sides by cosine theta. That gives me cosine squared theta equals 1. That means I can root both sides, and I'm looking for where cosine equals plus or minus 1. Okay, if we wanted to keep going, this one's a nice quick one. Where is cosine positive 1? At 0 and at pi. Since we don't want 2 pi as a solution because it's got the parenthesis, we can go ahead and stop there. So that was a nice quick one to solve. You know, in a problem like this was something we solved on day 1. Okay, if I take a look at the next one, it's 2 cosine squared theta plus cosine theta. Okay, so what do I want to do here to solve? Okay, so again, we've done one similar to this. That is a factoring problem. All right, I have a cosine in both, so I want to factor out that cosine, and that gives me 2 cosine theta plus 1. So then now I can just split it up, and I'm looking for where cosine is theta, and for where 2 cosine theta plus 1 equals 0, or if I went one step further, where cosine theta is -1/2. So I can look on my unit circle here, look on my unit circle there, and find those values from 0 to 2 pi. So I've got to factor out, pull out a GCF there of that cosine. All right, last couple that we're going to look at. This one is 2 cosine of 2 theta plus 3 equals 5 cosine theta. Okay, so again, I have a 2 theta here and a theta, so I've got to fix that. So if you remember back to your formula sheet, we've got 3 options for cosine of 2 theta. We've got cosine squared theta minus sine squared theta. We've got 2 cosine squared minus 1, and we've got 1 minus 2 sine squared. So the downside is we have 3 choices. We've got to pick the smart choice. When I look on this side, I see that I have a cosine. So I want to pick the one that has cosines. So that means I want to pick that guy right there, 2 cosine squared minus 1. If this side would have been sine, I would have wanted to pick the one on the bottom, 1 minus 2 sine squared, so that all I have left is sines. So what we're going to do here is we are going to go ahead and substitute in for that 2 theta. So I get 2, and then in parentheses, 2 cosine squared minus 1 plus the 3 equals 5 cosine theta. Okay, now this looks similar to the other ones that we've done. We distribute here, so that gives me 4 cosine squared theta minus 2 plus 3. I'm going to go ahead and move that 5 cosine theta over because we want to get everything on one side. So I get 4 cosine squared minus 5 cosine theta plus 1 equals 0. And now this turns into a factor and solve problem. If it doesn't factor, we also can use the quadratic formula. And again, I'm not going to continue this one because we've already done that. We know how to factor it or do quadratic formula and then solve from 0 to 2 pi on this one as well. All right, the last one I do want to go ahead and do and actually finish most of it, I think, is this last one. So I've got a sine equals 1 minus root 3 cosine theta. Okay, so one of the things that we always want to do is we want to get the square root all by itself. Well, in this case, the square root is attached to a cosine, so we're going to get that term all by itself. So I want to move that 1 to the other side. So I get sine minus 1 equals negative root 3 cosine theta. Okay, anytime we have sines and cosines, we're going to have to square both sides. Okay, so let's get rid of that root 3 as well, and let's square both sides exactly as it is right now. Okay, so again, squaring both sides means multiplying these out. So I've got a sine minus 1 times a sine theta minus 1. That gives me sine squared theta. Here I get a negative sign and a negative sign, so that gives me negative 2 sine, and then plus 1. On the other side, I've got negative root 3 cosine theta times negative root 3 cosine theta. That gives me positive 3 cosine squared theta. Okay, so again, we notice that we have sine squareds and we have cosine squareds, but I also have this plain sign right here in the middle. Okay, so that means I need to go ahead and I need to get rid of that cosine squared and make our substitution there. So I've got sine squared theta minus 2 sine theta plus 1. I need to get rid of that cosine squared by plugging in 1 minus sine squared. So let's keep going and clean this up a little bit. I've got a sine squared, a negative 2 sine plus 1, and that gives me a 3 minus 3 sine squared. Let's get everything on one side. So I'm going to add that 3 sine squared over here. And then I'm going to subtract the 3 as well. So that gives me 4 sine squared theta minus 2 sine theta minus 2 equals 0. All right, so I always want to try to factor first before I jump to quadratic formula. I can pull a 2 out here. So that gives me 2 sine squared theta minus sine theta minus 1. Okay, and this actually does factor nicely on the outside. We're looking for factors of -2. Well, there's only 2 factors of -2. That's 1 and 2. And if I want to get a -1, that means I need the 1 to be positive, the 2 to be negative. Since it has a leading coefficient of 2, I've got to divide both sides by 2. So that gives me a positive 1/2 and a -1/1. Throw my sine theta on the bottom. So that gives me 2 sine theta plus 1 is one of my factors. And then sine theta minus 1 as my other factor. Okay, so notice we have 3 parts here, but when I take that 2 and set it equal to 0, that doesn't give me a solution. But when I take the 2 sine theta plus 1 and set it equal to 0, that gives me sine is -1/2. And then the last one, when I take sine minus 1 equals 0, that gives me sine theta equals 1. So what I'm looking for is I'm looking for where sine is -1/2 and where sine is positive 1. So sine is -1/2 at 7 pi over 6 and also at 11 pi over 6. And then sine is positive 1 where theta is pi over 2. All right, so this is one of the ones where we squared both sides. So we have to check our answers. So I've got to take my solutions right here and I've got to plug them back in. So I've got to take 7 pi over 6, and I can actually do this with my calculator. Make sure you're in radians. And I've got to plug 7 pi over 6 in here. So sine of 7 pi over 6, which we know is -1/2. And then plug it in on the other side as well. And again, you can use your calculator to check. Type in 1 minus √3 times cosine of pi over 6. And you will notice that those two sides are not the same. Okay, now you've got to do the exact same thing with both 11 pi over 6 and pi over 2. Anytime you square both sides, you must check your answers. Okay, so plug in 11 pi over 6. That one actually does check. So here my only 2 solutions are 11 pi over 6 and pi over 2. Okay, so anytime you square both sides, you have to check your solutions, which makes me think that there was one problem here where I think we squared both sides, which was right here. I didn't finish this one, but if we would have gotten our solutions for theta, we have to make sure we check our answers. Okay, so again, we didn't finish this one, which is why I didn't check our answers, but I don't think I mentioned it. When you square both sides, that was our first step in that first problem. When I square both sides, we have to make sure we check our solutions. All right, that's all for today, and we'll have a My Math Lab assignment tomorrow.